Hi guys, and welcome back to another lesson in Algebra 1. This is for Unit 5, Lesson 2, and it is about graphing linear inequalities. And so how you know you are successful is, the first thing is you know when to use a dashed line or a solid line when graphing an inequality. And I can graph an inequality and I know what area to shade. Alrighty, so let's go ahead and get started with this. Grabbing my writing utensil. All right. So the first thing that we're going to do is we're going to convert the inequality to slope-intercept form. And then you will, you'll graph your dots. You'll graph your points. Okay. And so there is a rule to follow about which line type to use. So you can have two types of lines. You can have a solid line and you can have a dashed line. And they're solid and dashed for a reason. Okay, so we'll talk about that here in a second. So you use a solid line whenever you see the equal sign in it, like the greater than, less than or equals, or the greater than or equals. And the reason that it's a solid line is because a point that falls exactly on that line is a solution. That's why it's a solid line. Okay. Now, a dashed line, this is going to be when you have like a less than or a greater than, and it doesn't have the equal sign in it. The reason that it's dashed is because the point on the line is not a solution. Okay. And so there is a rule on how to shade. You will be shading these graphs. So not only do you have graphs that can have a line or a dashed line, you can shade above or below the line. So the general rule is going to be anything that's like, say, greater than or equal, you're going to shade above the line. And if it's less than it equals, it's going to be a shade below the line. Now, this here kind of seems arbitrary. Like, why would we say shade above the line or shade below the line, based on what the symbol is? The reason that we say this is because any point falling in the shaded area is a solution. And we can actually test points. Okay. So by that I mean is like, so I've got this, pro tip here. You can plug in a nice easy point, like the common easy point is 0, 0. And when you test with this, it'll tell you which way to shade. So you can plug in 0, 0 to test. And I'll show you what this looks like when we go down and we graph some equations. So, of course, I'm recording this ahead of time. So if I am going too fast, just give it a pause and I'm going to clear this off and I'm going to slide on down. Alrighty. So these first two graphs, thank goodness, they are in slope-intercept already, which makes our lives a lot easier. So this equation here, you got y is greater than negative 1/2 x plus 3. So I'm going to go grab this right here. And remember, this is my y-intercept. So at plus 3, I'm just going to put that point there. Boom, done. This guy here is my slope. And notice that it's got the negative. So my slope is going to be negative 1/2. That negative, remember, it means that we're going to build our line going up in this direction. versus positive going in the right-hand direction. So I like to make myself a little note so that I remember, because my brain will just kind of go on autopilot. And before I know it, I'm just graphing a line any old which way. So I'll make a little note saying it needs to go up in the negative direction. Okay, -1/2, that means we're going to go up 1 over 2. So we're going to go up 1 over 2, and we're going to build it so that it slants towards the negative. Now, the final thing that or not the final thing, almost final thing, the next to the final is we got to look at this guy here. So it's got a greater than sign. It does not have an equal sign in it. So because it doesn't have an equal sign in it, that means this is a dashed line. So I'm going to kind of freehand this. It's not the best, and yours doesn't have to be the best either. I'm not an artist. Now, one area of this graph will be the solution, and one area won't. This, if we remember kind of the rule, it says, above, we're going to shade above the line. Well, let me show you why that is. It's not just a made-up rule. There is a reason for it, and I can show you why. So we're going to test a point, and I'm going to pick the easiest point there is to test, which is 0, 0. So, my equation, if I write it over again, so I can just kind of get my head in the game here, y is greater than -1/2 x plus 3. I'm going to substitute 0 in for, whoops, that's in the y position. I'm going to substitute 0 in here and 0 in here. So I got 0 is greater than -1/2 times 0 plus 3. So this bad boy cancels out, and then we just get 0 is greater than 3, which should make you go, what? 0 is not greater than 3. This is a false statement, right? If it is false, that means no points where, like, this is not a solution. Not a solution. Okay? It means this way is a solution. So every point over here, this point, and this point, and going to infinity, this point, and this point, all these points are solutions. Another thing that is not a solution, because this is a dashed line, I just want to point out, this point, not a solution. This point, not a solution. Okay, so anything that falls directly on the line is not a solution if it's a dashed line. Alrighty, so you might need to know that at some point in time. Let's go graph this next line. And so fortunately, here it again is in slope-intercept. This is my y-intercept. So it's -4. I'm just going to go down here, boom, put a point in. My slope is right here, and it looks like I don't have a slope, like there's no number written there. But of course, that means that there's an understood one, because if there was no number there, you wouldn't see the x at all. Like if there was no slope, you would see something like y is greater than or equal to -4. You wouldn't see the x at all. But because there is an x there and there's no number written, we know that it's an understood one. So when it's an understood one, it just means that we're going to go up 1 over 1, because that's the fraction, 1 over 1. It is positive. I'm going to go over here to the positive direction when I'm building my slope. So I'm just going boing, 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 going this way. Now, this guy has an equal sign in it. Okay, so because it's greater than an equal, that equal sign is telling me it's going to be a solid line. So this will be a solid line, no dash. And because it's a solid line, it's easier for me to graph on the computer, because I can just use my tool and I can go and draw a line. Alrighty, now our next step is we've got to decide which way to shade. So I am going to test. I can test my 0, 0. Now, this tells me it should be above the line. So we know we should be shading probably this way, but I'm showing you why. It's not just a rule that says, here, memorize this. If it's greater than, shade above the line. There's a math reason. And knowing how to test a point is a very good skill to have. So we're going to do y is greater than or equal to x minus 4. I'm going to plug my zeros in. We got 0, 0, 0 is greater than or equal to -4. That is a true statement. And so we know then this point here is a solution. So everything over here on this side, all of these points, there's like infinite number of points in this direction, is a solution. Because it's a solid line, every point on the line itself is a solution. Okay, so every one of these would make a true statement all along this line. Alrighty, I am going to erase. If I'm going fast, just pause it. So I'm going to erase and slide on down. Just giving you a little bit of warning. Ready, set, go. Here we go, going on down. Alrighty, let's look at this part. Now these two are in standard form, so we're going to have to do a little bit of rearranging to make this happen, but we can do this easy peasy. I want to remind you that your slope-intercept formula looks like this. That's y equals mx plus b. So to graph easily from slope-intercept, our x is on one side and our y is on the other. And notice there are no numbers other than an understood 1 in front of that y. So we can't have a negative y or a negative 2y or anything like that. Let's see. Let's go ahead and write everything out. So I've got negative 4x or minus 4x. I'm subtracting 4x from both sides. This cancels. I get negative 2y is greater than negative 4x plus 8. I want to point something out to you. This is a big deal because when we divide by negatives with an inequality, this negative right here, when we divide or multiply by a negative, we're going to have to flip that sign. So let's do this. So I'm going to divide by my negative 2. I have to do all three terms by negative 2, negative 2. This cancels. I bring down my y. This guy flips. So it's going to go this way. Negative 4 divided by negative 2 is going to give me 2x. 8 divided by negative 2 is going to give me negative 4. Now I can graph. My negative 4, drop a point here, boom. 2, that slope is 2 over 1, right? So I'm going to go, oh, and it's positive. So I'm going to go over here in the positive direction. I'm going up 2 over 1, up 2 over 1, up 2 over 1, and so on. Now, this guy here, there is no equal sign in it. Okay? So because there's no equal sign in it, I know it's going to be a dashed line. So I'm going to do the best I can. Dash, 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 dash. Now, quick question in your head is, what does a dashed line represent? It means any point on this line is not a solution. That's why it's dashed. It's saying everything up to there, it could be a solution, but once it touches that, boom, not a solution anymore. Now, this guy here is telling me, the less than is telling me that we're going to shade below the line. So we should be shading in this direction, but I'm going to test it real fast because I want you to feel comfortable with the math reason why it works this way. Okay. So let's see, we're going to just test a nice easy point, which is 0, 0. And so I can use this equation or I can use this equation. It really doesn't matter. As long as my algebra was correct between these two equations, you should get the same answer. We can try it in this first one. We can do 4 times 0 minus 2 times 0 is greater than, whoops, 8. I don't know why I wrote that 0 again. I guess I was just 0 on the brain. So 0 is greater than 8. What? That is clearly false. That is not an accurate statement whatsoever, which means over here, this is not a solution. Not working. So everything in this direction is the solution. That's why the little trick about remembering, and I want to make sure you know this. We're using this one, the final rearranged one, to decide we're graphing on the underside. If you looked at the original equation, you would graph the shaded area in the wrong way. Okay. So I kind of forgot my point with that, but I just wanted to make sure that you know why we shade this way. It's not just some sort of made up rule. There is a math reason for that. All right, let's go ahead and look at this one. This one's in standard form. We've got to get it in slope-intercept, and we remember slope-intercept looks like this. So I'll just go ahead and rewrite my equation so I can get organized in my brain. And I'm going to move my x over, so I'm going to subtract my x. This cancels. I get 3y is less than or equal to negative x plus 6. I cannot have a 3 in front of my y. It has to be a 1. So I'm going to divide by 3. And I've got 3 terms here, so I've got to divide by 3 on all of them. This cancels. My y is less than or equal to negative x divided by 3 is going to give us this fraction, negative 1/3 x. Plus 6 divided by 3 is 2. Now I got something I can graph. Notice my slope is negative. I'm just going to make myself a little note here because this is part of the way that I get my brain, because my brain will squirrel around doing all kinds of goofy things. So I will make myself a note saying, I got to go up to the upper left side. And so I'm going to go up 1 over 3. And so the thing is, like if I'm an adult and a teacher and my brain will squirrel around doing goofy things, of course students do that, because you're a human being. So that's why I make little notes to myself. And I would suggest to my students that you do the same. Okay, this has an equal sign in it, so I'm just going to go ahead and graph that line like this. It does not have a dash. The reason it does not have a dash is because every point on that line is a solution. So even though I didn't draw my line very well, this point is a solution. Okay, yeah, that's a solution. This is a solution. So is this one here, even though it's in between. That's a solution. Anything that falls on this line is a solution. We got to decide which way to graph. This is saying we're going to graph on below the graph, so it should be this way. I'm going to prove to myself, okay? I'm just going to double check my math because what if something weird happened? So I can test, and I can test 0, 0. So I've got my x plus 3y. X plus 3y is less than or equal to 6. Plug my 0 in. Plus 3 times 0, less than or equal to 6. So that's 0 plus 0, so 0 is less than or equal to 6. This is true. Okay, so when we shade in the direction where the 0 is, all of these points over here are possible solutions because they fall into the area where it is a solution. Alrighty, my friends, this is the end of the notes for today. Pause it if you need to. So I'm giving you a little bit of warning before I close it out. Until next time, my friends. Bye.